In today's masterclass, what we are going to do is we're going to complete all the reactions of carboxylic acids. We will do acidity of carboxylic acid and then finish off the chapter with physical properties of carboxylic acids. So let's start, students. Before we start, I want you all to make sure that you have gone through the previous lecture, and at the same time I want you all to please like, subscribe and share this lecture with your friends and all the students who are preparing for entrance exams. So the first reaction of carboxylic acid is the formation of anhydride. Let's, students, first understand what do you mean by an anhydride. Anhydride is when we remove water. Just like hydration is giving water, anhydride is like removal of water. So if I have carboxylic acid and I remove water from 2 units of carboxylic acids by using, let's say, H2SO4 heating or P2O5, you can say this is intermolecular dehydration. So we are removing water over here. Dabba mechanism में अगर हम देखें तो, so this is H2O and I am left with R, C double bond O, O, C double bond O, R. This is called as acid anhydride. So you write the name of the acid and you write anhydride in front of it. This is the first reaction, and let's move ahead with the second reaction. Very important reaction that we have is called as esterification. Now people, esterification आप लोगों ने alcohols, phenols, ether में भी पढ़ा होगा, but let's understand esterification once again. I have carboxylic acid. Along with that, I have alcohol. Now, the thing that we should be careful about over here is this reaction is reversible in case of an acid. And यहाँ पे क्या होता है? The OH is removed from the carboxylic acid. H is removed from the alcohol. You need to remember this. I repeat, OH from the acid and H from the alcohol. And what we get here is ester. Basic ester nomenclature भी लिख लेते हैं. The group which is attached to oxygen हम पहले लिखेंगे alkyl, and from the remaining part of the compound nomenclature becomes alkanoate. Now students, this is not the actual mechanism. ये तो हमने डब्बा mechanism के through किया, but this, let's understand this reaction according to the actual mechanism of the reaction. This mechanism is also called as nucleophilic acyl substitution. Let's understand nucleophilic substitution or nucleophilic acyl substitution mechanism. Now, in step 1, the H plus that we get from our catalyst protonates the carbonyl oxygen. So what's happening, students, over here is protonation of carbonyl oxygen, and हमारे पास है R C double bond O. Oxygen here had two lone pairs. One of them is now with the one lone pair is now with the proton. So this is step 1, where you have protonation of the carbonyl oxygen. Next step, what happens is these electrons resonate. Oxygen पे जो positive charge था will no longer be there because oxygen will get lone pairs. ये जो double bond है उससे आ जाएंगे. And what happens is the carbon here gets a positive charge. Now comes the second very important step in the reaction, where the alcohol comes into picture. So ये है आपका alcohol. ये carbonyl carbon पे we see a positive charge. This is your rate determining step, और आपका slow step कहते हैं इसे. So we have R C OH, again OH, and ये attach हो गया. So next step students, ये जो H है, these electrons will go to oxygen as lone pair, और ये आपका प्रोटॉन ये ऑक्सीजन के पास चला जाएगा. इसे हम बोल सकते हैं इंट्रामोलिक्यूलर प्रोटॉन एक्सचेंज. So a small proton exchange takes place, and what we have is R C O H, and one of the lone pairs is borrowed by this proton. So the oxygen here gets a positive charge OH, and यहाँ पे आपका आ गया OR dash. Next step, these electrons will be taken. ये bond break हो जाएगा इस कार्बन के साथ. So you have R C OH OR dash. ये कार्बन पे आ गए पॉजिटिव चार्ज, एंड H2O. फाइनली ये लोन पेयर्स यहाँ पे आ जाएंगे टू हेल्प द कार्बन एटम. सो यू हैव R C डबल बॉन्ड O OR dash. बट अब ये ऑक्सीजन पे देयर विल बी पॉजिटिव चार्ज. एंड लास्ट स्टेप में हमें कैटलिस्ट वापस चाहिए. सो द कॉन्जुगेट बेस HSO4 माइनस विल एक्सट्रैक्ट द प्रोटॉन. आपको आपका कैटलिस्ट भी वापस मिल गया in the form of H2SO4, and what we get here is the ester. So people, this is the mechanism of the reaction. It's a very very important mechanism. आपको कोई भी doubts है, कोई भी questions regarding the mechanism, please leave your comments behind. Now students, the next reaction is formation of acid chlorides. आप बोल सकते हो, या ये रिएक्शन में हम क्या करें, reaction of carboxylic acid with phosphorus trichloride, phosphorus pentachloride, and thionyl chloride. Now I'm sure students ये reaction आपने already पहले किया है in the chapter in the chapter haloalkanes, haloarenes, and also in alcohols phenol. It's very similar to that reaction, जहाँ पे the hydroxy group, OH group is replaced by Cl, we are doing the exact same thing over here. So in carboxylic acid, I repeat, OH group को हम replace करेंगे, and react that with PCl₃, we get R C double bond O Cl. So the OH is replaced by Cl, plus we have phosphorus acid. Let's balance that out. So this is the reaction. So converts carboxylic acid to acid chloride. या ये जो OH है, that OH is just replaced by Cl. Next, carboxylic acid plus phosphorus. Instead of phosphorus trichloride, we have phosphorus pentachloride. Exactly the same product, acid chloride, plus we have HCl and phosphorus oxychloride. Reaction is already balanced, and the last reaction, carboxylic acid plus we have thionyl chloride, and this is done in the presence of pyridine, excess HCl को हटाने के लिए. So the product that we get over here, it remains the same. You also get HCl and we get SO2. Now the best thing about this reaction is the byproducts that we get in this reaction. The byproducts are gaseous in nature. So out of all the methods, the best method to replace the hydroxy group by chlorine Cl is by using thionyl chloride. That's the third reaction. Now let's move ahead, students, to the next reaction. Again, a very, very important reaction. This is reaction of carboxylic acid with ammonia. A very important reaction, people. काफी रोड मैप टाइप रिएक्शंस में ये यूज होता ही है. So carboxylic acid, as the name itself says, acid, and ammonia we know is a proton acceptor, electron pair donor. तो ये हो गया acid base reaction. Acid base reaction will give us salt. तो हमें ये salt मिलता है. You can say this is ammonium carboxylate. And on heating, आप बोल सकते हैं नॉट द एग्जैक्ट मैकेनिज्म, डब्बा मैकेनिज्म आप कर सकते हैं कि यहाँ से हमने H2 निकाल दी, यहाँ से O निकाल दी, H2O चला गया. व्हाट वी गेट हियर इज अमाइड. नॉमेनक्लेचर में हम इसे बुलाएंगे अल्किन अमाइड, एंड वी हैव H2O. So this converts carboxylic acids to amides. Now let's do this reaction for phthalic acid. I repeat, इसे हम करते हैं for phthalic acid. So phthalic acid plus we need for one COH एक अमोनिया, तो यहाँ पे हम ले लेंगे 2 NH3s. So acid plus base will give us salt. O minus NH4 plus C double bond O minus and NH4 plus this on heating, just like H2 and O from here, यहाँ पे भी H2 and O, यहाँ से भी we will remove H2 and O. So what we get over here is phthalamide. I repeat, what we get over here is phthalamide. Now students, phthalamide on further heating, we remove NH2 and 1H from here, NH3. I repeat, NH2 and 1H from here, and what we get is phthalimide. Now, phthalimide is a very, very important agent because we'll be using phthalimide and doing something called as Gabriel phthalimide synthesis in the chapter amines. तो आप phthalimide को याद रखना. And इस reaction को थोड़ा सा और बनाने के लिए, can someone tell me some preparation technique of phthalic acid? How do I get phthalic acid? Let's say, how do I get phthalic acid from orthoxylene? Yeah. एक टेक्निक जैसे कि how do I reach phthalimide from, let's say, this compound, or how do I get phthalic acid from orthoxylene? Give your answers, students, in the comment section. How do I convert orthoxylene to phthalic acid? And let's say do this reaction, or I start from 1,2-cyanobenzene and reach phthalimide. So this was the next reaction, which is reaction with ammonia. Let's move ahead with the next very, very important reaction, which is decarboxylation of sodium salts of carboxylic acid. Very important method, decarboxylation of sodium salts of carboxylic acid. I'm sure students, you are already done this in the chapter alkanes, because we study the same method as a method of preparation of alkanes. So in decarboxylation of sodium salts of carboxylic acid, we need to first prepare a sodium salt of carboxylic acid. So carboxylic acid किसी भी electropositive metal के साथ, just like alcohols, acids will react with any electropositive metal and produce hydrogen gas. और along with that, ये हो गया आपका सोडियम सॉल्ट ऑफ कार्बोक्सिलिक एसिड, या सोडियम अल्कनोएट भी हम बुला सकते हैं इसे. Now this sodium salt of carboxylic acid, sodium alkanoate, with slaked lime, which is NaOH and CaO, in the ratio of 3:1. ठीक है, if we just look at the डब्बा mechanism, ये part बाहर आ जाएगा. So ये एक drying agent का काम करता है, CaO. The reason we need a drying agent in this reaction, students, because if there's moisture present in the reaction, so reaction में थोड़ा problem हो सकता है. That's why I need a drying agent, NaO, and this part comes out and ये बन जाता है Na2CO3, and we get RH, which is your alkane. Now students, this is not the exact mechanism. However, I'll still give you an overview. The reaction, or the reason we call it as decarboxylation, is decarboxylation means removal of CO2. It's a removal of carbon dioxide. Now, from the sodium salt of carboxylic acid, ये जो आपका sodium salt of carboxylic acid है, the carboxylate anion which is there, CO2 is removed and along with that we get a carb anion in the reaction. I repeat, we get a carb anion, and hence, very important point, students, decarboxylation, if you want to increase the rate of decarboxylation, you should have an electron withdrawing group, or I repeat, electron withdrawing groups increase the reactivity towards EWGs. Electron withdrawing groups increase the reactivity towards decarboxylation. So I hope everyone knows what electron withdrawing groups are. So electron withdrawing group present होगा अगर आपके sodium salt पे, let's say यहाँ पर, or some, let me give you an example. So यहाँ पे Cl negative minus I effect, electron withdrawing effect, and that will increase the reactivity towards decarboxylation. This was the fifth reaction. Let's move ahead, students. Again, sixth reaction is something which again 11th standard में I'm sure students आप लोगों ने किया है, which is Kolbe's electrolysis. But let's do Kolbe's electrolysis. डब्बा mechanism में थोड़ा सा इसको फिर से करते हैं. For Kolbe's electrolysis, again we need a sodium salt of carboxylic acid, or you can also have a potassium salt of carboxylic acid. And hum students, we are performing electrolysis. So electrolysis ka solution banana hai. So we have that salt in water, and I repeat, we are performing electrolysis. Everyone knows electrolysis mein there is a cathode, there is an anode. Dabba mechanism समझते हैं. This is the first product, H2. Then हमारे पास है NaOH, basically OH minus. Then we have CO2 and higher alkane, we get an alkane. Now students, this part is obtained at the cathode, we can say. H2 gas actually is obtained at the cathode, and हम बोल सकते हैं ये part is the part that we get at the anode. Okay, now though this is not specific to preparation of only alkanes, I'll write two reactions, and students आप मुझे बताना what will be the product obtained if you perform electrolysis of the following sodium salts. I repeat students, I'll write a few examples. आप लोग मुझे बताना what is the product obtained. For example, let's say sodium salt of succinic acid. इसका अगर हम Kolbe's electrolysis करें, what will the product be? And let's say for example हम लेते हैं okay sodium malate. Okay, so what if we perform the electrolysis of these two salts, succinate, sodium malate? If you perform the Kolbe's electrolysis for these two salts, let me know in the comment section what is the product that we're going to get at the cathode and at the anode. This was Kolbe's electrolysis. Now let's move ahead, students, to the next reaction. Again, a very, very important reaction. I think reaction number 7, which is reduction of carboxylic acid. Now students, in reduction of carboxylic acids, कुछ very important points there are some very important points that we have to notice. We have to note down. The first point that we have is, see, carboxylic acid on reduction produce primary alcohol. So acids on reduction produce primary alcohols. We also know that alcohols on strong oxidation and strong oxidizing agent will go to carboxylic acid. Now this reduction can be done using lithium aluminium hydride, or we can use diborane. But एक point, students, we need to remember that we cannot use sodium borohydride. So the first important point, students, that we need to remember is NaBH4 does not reduce carboxyl group. So this is the first point that we should remember, students, that NaBH4 sodium borohydride does not reduce carbonyl group. And second point is diborane does not reduce ester, nitro group and halo group. So this is the second point that we need to remember in reduction of carboxylic acids. Now the last two reactions which are left. Now the next reaction that we have, people, is called as Hell-Volhard-Zelinsky reaction. Very, very important. इसे हम दोनों मेथड से समझेंगे. We will understand this via the mechanism of the reaction. We'll also understand this using the Dabba mechanism. So let's start, student, by using with the easy way, Dabba mechanism way में हम समझते हैं. What HVZ reaction does is it converts a carboxylic acid containing alpha hydrogen. Alpha hydrogen क्या होता है, students? Carbon which is bonded to the functional group is called as alpha carbon, and hydrogens which are bonded to the alpha carbon, these are called as alpha hydrogens. So the alpha carbon and alpha hydrogen and red phosphorus and your halogen, alpha hydrogen is replaced by halogen. Alpha hydrogen, I repeat, is replaced by halogen. This is the reaction, students. So what we have here is alpha halo carboxylic acid. Very important. Now, students, the thing is, if this is present in excess, if you take the reagent in excess, it will replace all the alpha hydrogens available. I repeat, यहाँ पे I can also write this as px3, and if I use this in excess, all the alpha hydrogens present will be replaced. Also, if there is no alpha hydrogen present, so let's say अगर हम कुछ ऐसा example ले लें, so alpha carbon तो है, but there is no alpha hydrogen. अगर alpha hydrogen नहीं है, then no HVZ reaction. HVZ reaction does not take place in the absence of a alpha hydrogen. Okay, students, but this was not the exact mechanism. So let's understand this कि HVZ reaction का actual mechanism क्या है. It's a very interesting mechanism. So in the first step, with px3, let's say I'll take PBr3 मैं ब्रोमीन ले लेता हूँ in order to understand. This exact reaction is replacement of OH. So first step में यहाँ पे OH is replaced by Br. मैं अल्फा कार्बन डालना भूल गया था, pardon me. So OH is replaced by Br in the first step. And now students, this undergoes a rearrangement in the form of tautomerism. I'm very sure that students knew about tautomerism. नहीं पता तो you can watch the video on tautomerism. H shifts here, ये double bond यहाँ पे shift हो जाए, so we get R CH double bond C OH and Br. Now students, let's carefully observe the next step. Next step, students, what happens is during resonance यहाँ पे R CH C OH. So I am breaking down the steps. ये double bond के electrons, I've taken them onto this carbon, and यहाँ पे this carbon gets a plus charge and Br. And so these lone pairs, they will come over here, and we have R CH carbon ion, carbon के ऊपर I C lone pairs, carbon doubly bonded to this oxygen Br. Oxygen which previously had two lone pairs now has only one, so oxygen gets a plus charge. Now what happens here students? आपका जो Br2 है, so this will extract Br and ये बन जाएगा Br minus. So we have R CH, ये लग गया आपका अल्फा हाइड्रोजन पे Br, C double bond O H, oxygen still has that plus charge and Br, and यहाँ का Br minus will extract this proton और ये इलेक्ट्रॉन्स ऑक्सीजन को मिल जाएंगे एज लोन पेयर्स. तो आपको मिल गया HBr प्लस R CH Br, we have C double bond O and Br, and finally this on hydrolysis gives us the alpha Hell-Volhard-Carboxylic acid. This is the mechanism of the reaction. Now students, we need to really understand this because बहुत सारे points और हम याद रख सकते हैं. देखिए जैसे कि ये एक chiral carbon है, so this can be further taken to produce, let's say आप start कर सकते हो from acetic acid or ethanoic acid and reach lactic acid via this method. Let's say if anyone can show me comments में how do you go from acetic acid to lactic acid, not the way we have done it in aldehydes and ketones nucleophilic addition reaction में, but इस method से हम कैसे जा सकते हैं. The next reaction students that we have, I think that is reaction number 9, which is heating of dicarboxylic acids. Now students, this is a very important reaction because this involves the fundamentals of decarboxylation. So thoda JEE advanced, especially for students who are preparing for JEE advanced, for advanced exams, this reaction is very important. Heating of dicarboxylic acids. So let's start with the first dicarboxylic acid students. First dicarboxylic acid हमारे पास है is oxalic acid. So oxalic acid students on heating, this gives us CO, CO2 and H2O. So oxalic acid on heating gives us CO, CO2 and H2O. This is our first dicarboxylic acid. Students, second dicarboxylic acid जो हमारे पास है, which is malonic acid. Malonic acid. On heating, what happens here is this is removed, CO2, decarboxylation, and we have CH2, COOH और ये H बन जाए CH3, COOH. We get ethanoic acid. I am teaching the students via the Dabba mechanism. We are not doing the actual mechanism of the reaction. So malonic acid on heating will give us ethanoic acid. Let's move ahead to the next dicarboxylic acid. So the next dicarboxylic acid is, students, succinic acid. I repeat, students, this is succinic acid. Now succinic acid on heating, students, again it dehydrates. ये हमने निकाल दिया H2O and we are left with we get this. This is succinic anhydride. I repeat, students, we call this as succinic anhydride. So this was decarboxylation of succinic acid. Then the next acid that we have is called as, students, glutaric acid. I repeat, इसे हम कहते हैं glutaric acid. Now students, glutaric acid again on heating, this comes out. ये आपने H2O निकाला, and just like succinic anhydride, students, just like succinic anhydride, हमें मिलता है glutaric anhydride. I repeat, just like succinic anhydride, we get glutaric anhydride. And let's do one more. The next carboxylic acid, the next dicarboxylic acid that we have, students, is adipic acid. Now adipic acid, students, on heating, ये आपने dehydrate किया and you remove CO2 भी. So dehydration भी हो रहा है, decarboxylation भी हो रहा है, and what we get here is cyclopentanone. So students, these are very important from JEE Advanced perspective because we are studying the concept of decarboxylation of sodium salts of carboxylic acid. So similar concepts of decarboxylation based questions they can ask for dicarboxylic acids. And the last reaction, students, before we move on to acidity of carboxylic acids, is ring substitution. Now students, in ring substitution, what we do is electrophilic substitution reaction. Electrophilic substitution reaction. Now what we do in electrophilic substitution reaction, students, is we start with benzoic acid. Now students, only point that you need to remember here is carboxylic acid, COH, यहाँ पे is a meta-directing group. Or you can say that this is orthopara deactivating group. So this benzoic acid का आप कोई भी electrophilic substitution reaction करो. For example, if we have concentrated nitric acid and concentrated sulfuric acid, the attacking electrophile, which is NO2, that electrophile gets attached at the meta position. And let's say we do one more reaction in which we have, let's say हम halogenation कर रहे हैं, Br2, हमारा Lewis acid, FeBr3, then the incoming electrophile gets attached at the meta position. So these were all the different chemical reactions. Now let's move on to very, very important topic, which is acidity of carboxylic acid. Now students, in acidity of carboxylic acid, the first thing that we need to remember is we are breaking the bond between O and H. It's the cleavage of the OH bond. We're breaking bond between O and H. Now students, carboxylic acid, just like alcohols, they're very reactive towards electropositive metals and they release hydrogen gas. Now, since carboxylic acids are stronger acids, they also react with weaker base such as sodium carbonate and sodium bicarbonate, and we study this as sodium bicarbonate test. Now, if I react phenols, phenols do not react with sodium bicarbonate, but benzoic acid, alcohol sub, carboxylic acids do. So you can use sodium bicarbonate test as a test to detect or identify carboxyl group. Now students, carboxylic acids, aqueous solution में they will give H plus. If I write the equilibrium expression, ये हमारा dissociation constant का expression आ जाएगा. And acids on donating H plus, ये आपका conjugate base है. The carboxylate ion is your conjugate base. Now students, stabler the base, stronger is your carboxylic acid. आपका base जितना ज़्यादा stable है उतना ही strong आपका carboxylic acid है. And a very important point to remember is the presence of electron withdrawing groups. यहाँ पे एक list भी लिखा है according to their strength. The presence of electron withdrawing groups increases the stability of the conjugate base. It stabilizes the carboxylate ion, and that is why electron withdrawing groups increase acidity, electron donating groups decrease acidity. I repeat, electron withdrawing groups increase acidity, electron donating groups decrease acidity. Also, acidity can be measured in terms of dissociation constant Ka or in terms of negative log of Ka. इसका मतलब pKa. Higher the Ka, जितना ज़्यादा Ka, उतना ही कम pKa. Lower will be pKa value, but stronger the acid. Now students, carboxylic acids are stronger than phenols. And the reason for that is, see students, if I look at carboxylic acid, the conjugate base, which is carboxylate ion, so the electrons are resonating in between the electronegative oxygen atom. But that's not the case in phenol. See, phenol on H plus, जैसे phenol H plus दे देता है वो बन जाता है phenoxide ion. Remember, phenols में हमने पढ़ा है phenoxide ion is a very stable ion, but when phenoxide ion resonates, the electrons in the ring are resonating or increasing the electron density on carbon, and that's not the case over here. So you can see that the comparison between a carboxylate ion and phenoxide ion, carboxylate ions are more stable, hence making carboxylic acids stronger acids than phenol. But remember people, phenols are more acidic than alcohols. आप ये बात ध्यान में रखना. And if you want to study more about the acidity of phenols and the acidity of alcohols, we've done that in the chapter alcohols, phenols and ethers. नेक्स्ट स्टूडेंट्स, मैंने कुछ ट्रेंड आपके लिए पहले से ही लिख के रखे हैं. However, I will give you an overview of these trends. Please make sure that you note them down. First, as the size of the alkyl group increases, acidity will decrease. ऐसे क्यों होगा? Because of electron donating tendency, plus I effect यहाँ पे काम करेगा and it decreases the acidity. नेक्स्ट, यहाँ पे आप देखो तो 3 फ्लोरीन है, यहाँ पे 2 फ्लोरीन है, यहाँ पे 1 और यहाँ पे नन. एंड ये सारे डिक्रीजिंग ऑर्डर ऑफ एसिडिटी है. मोर द नंबर ऑफ इलेक्ट्रॉन विड्रॉइंग ग्रुप्स, हायर द एसिडिटी. ये आपका सेकेंड ट्रेंड है. सिमिलरली थर्ड ट्रेंड में पीपल, इफ यू सी यहाँ पे भी प्लस आई, इसका प्लस आई विल बी स्ट्रॉन्गर देन इसका प्लस आई. ये अल्काइल ग्रुप का प्लस आई विल बी मोर स्ट्रॉन्गर देन दिस. And last में this group will have the strongest plus I. As the electron donating tendency will increase, acidity will decrease. Next trend. Closer the electron withdrawing group to the functional group, stronger the acidity. जितना close है EWG, उतनी ज़्यादा acidity. Stronger the electronegativity, yes, stronger the electron withdrawing strength, higher the acidity. Let's take some examples in aromatic acids. यहाँ पे students कुछ point important ध्यान में रखने हैं. The first point is ortho substituted acids are the strongest. I repeat students, ortho substituted acids are the strongest because of ortho effect. ये हमने डिटेल में GOC में पढ़ा है, जनरल ऑर्गेनिक केमिस्ट्री में. एंड दैट्स व्हाई इफ यू ऑब्जर्व ऑर्थो सबसे पहले है. देन ME मिथाइल यहाँ पे स्टूडेंट्स इलेक्ट्रॉन डोनेटिंग का काम करेगा. इट विल पुश द इलेक्ट्रॉन पेयर्स अवे फ्रॉम इट एंड दैट इलेक्ट्रॉन डोनेटिंग टेंडेंसी डिक्रीजेस एसिडिटी. That decrease will be the most pronounced at para position. तो para position में सबसे stronger way में donate करता है, इसलिए acidity वहाँ पे सबसे कम होती है. Similarly यहाँ पे मैंने electron withdrawing group लगा दिया है. Electron withdrawing group, as we know students, increases acidity. Ortho effect की वजह से again ortho substituted acid is the strongest acid. Just like electron donation पैरा पे सबसे ज्यादा प्रोमिनेंट है और सबसे ज्यादा एसिडिटी कम कर देता है. सिमिलरली इलेक्ट्रॉन विड्रॉइंग टेंडेंसी इज आल्सो प्रोमिनेंट एट पैरा पोजीशन. इफेक्टिव होगी एट पैरा पोजीशन में, उतनी ही एसिडिटी बढ़ाएगी. एंड दैट्स व्हाई वी हैव पैरा नाइट्रोबेंजोइक एसिड एज द सेकंड स्ट्रॉन्गेस्ट एसिड हियर. आई हैव गिवन सम मोर एग्जांपल्स स्टूडेंट्स. यहाँ पे मिथॉक्सी अटैच है. मिथॉक्सी में हमें एक बात ध्यान में रखना है, यहाँ पे तो ऑर्थो इफेक्ट काम कर रहा है. मेटा पोजिशन पे ना स्टूडेंट्स उसका माइनस आई काम कर रहा है, बट एट पैरा पोजिशन उसकी इलेक्ट्रॉन डोनेटिंग टेंडेंसी प्लस एन प्लस आर काम कर रही है, मोर एज कंपेयर टू ऑक्सीजन की माइनस आई. सो द इफेक्ट ऑफ माइनस आई इज लेस. द इफेक्ट इलेक्ट्रॉन डोनेटिंग टेंडेंसी इज स्ट्रॉन्गर एट पैरा. But meta पे only minus I of the oxygen is working. Next example, यहाँ पे इंटरामोलिक्यूलर हाइड्रोजन बॉन्डिंग है स्टूडेंट्स. इंटरामोलिक्यूलर हाइड्रोजन बॉन्डिंग. This produces a very stable 2,4 dihydroxy कार्बोक्सिलेट आयन. यहाँ पे बेंजोएट आयन बनता है यहाँ पे. जो इंट्रामोलिकुलर हाइड्रोजन बॉन्ड बनाता है इस OH पे, ये H के साथ और ये H के साथ भी, अगर भी स्टूडेंट्स शॉर्टकट पे बनाओ तो कुछ ऐसे दिखता है वो। यहां पे देखो, ऐसे इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग होती है इसमें। दिस इज 2,6 डाइहाइड्रोक्सी बेंजोएट आयन, and over here students we have an effect which is called as steric inhibition of resonance, SIR effect, short form में people SIR effect बता दूं। so COH का plane ही different हो जाता है over here, it's in an altogether different plane, that is why ये सबसे ज़्यादा acidic है, and then this and then this। Students, we are not able to do this एकदम in detail because हमने ही already GOC में किया है, but such are the trends, these are few trends that students you should remember, और इसके आसपास के concept base पे they can ask you more questions। Finally, let's just go through some basic points, boiling points. Students, carboxylic acids have very high boiling points compared to those of, they have higher boiling point compared to aldehydes, ketones, ethers and alkanes of comparable molecular mass, क्योंकि students they have hydrogen bonding, उनकी hydrogen bonding बहुत strong है। It is so strong that in vapor phase, students, in vapor phase they form something called as a dimer। di का मतलब होता है two, mer का मतलब होता है unit। If I look at their solubility, students, simple carboxylic acids, they are soluble in water up to carbon number 4. As the size of the alkyl group increases, the solubility decreases, solubility of carboxylic acid decreases. Benzoic acid, students, is almost insoluble in water. They are, however, soluble in inorganic solvents such as, they are soluble in polar solvents such as, less polar solvents such as benzene, ethers, alcohols and chloroform. So students, this completes carboxylic acid reactions. If you have any doubts or any questions, or if you want any other concepts to be taught more thoroughly, please leave your comments behind. Thank you so much, and please make sure that you subscribe and you share this video with all your friends. Thank you so much.